Hi, this is Hans from Tundra Feed and Supply Company. Today we're going to talk about Godot 4 fundamentals for top-down character movement. In this, we'll cover setting up your scene and project, character body 2D, along with an introduction to the concept of nodes, inheritance, and composition, collision shape 2D, input maps, attaching a camera, and the code tying all of this together. Okay, let's go about what we're trying to accomplish. For 2D character movement, we need the player to be able to move in 4 directions: left, right, up, and down. We also need the player to point to the user's mouse or through some other means of control, so rotation will be important. We don't need to jump, as our X and Y axes are already in use by our left, right, and up-down movement. And our Z axis, as this is a 2D game, is technically not in use. So let's dive in. Okay, so now that we're in an empty project, this is the Godot 4 screen. So looking around this briefly, we can see that we have our main scene here in the middle. And then on the left, we have our scene and import tabs, we have our file system, and then on the right, our inspector, node, and history. Now, these 3 dots in each of these docs, if we click on them, actually opens up a settings menu. Now, what you'll notice from here is that there's a big blank area in the middle, and then there's sort of darker gray areas on the left and right, and then these beige areas here towards the center. So these are where our current docs are set to be. This is the standard layout for Godot. However, if you'd like to move these, you're more than welcome to. For instance, when you're making a larger game, your file system might become larger than what can be shown here. And depending on how frequently you interact directly with the file system, you may want to have this doc be a little bit larger. If we'd like to do that, we can go ahead and click on the dots here in the file system doc. And we'll go ahead and click this icon right here. And that will move the file system to the left next to our scene doc. This is now a much larger space for us to navigate and look for files or folders within. Speaking of the file system, this is our main directory here. Yours should look pretty much just like this. However, mine has a README in it as well since I'm using Git. From here, we can go ahead and add subfolders as we develop our project. For instance, when we begin to add art, we might create an assets folder. I went ahead and did that by right-clicking in this file system doc and clicking new folder and then typing the folder we want to add. Later on, as we start developing our scenes, we may create a scenes folder as well. And from here, we can continue to develop our game out. However, that's not critical for now and not something that we'll be delving further into. So you can go ahead, if you made those, you can go ahead and delete them if you would like. Okay, so finally, you can move the docs for all of these. For instance, if you'd like the inspector to be under our scene, we can go ahead and click its doc icon and move it below the scene doc here. Now, you'll notice this didn't disappear, and that's because each of these individually can be moved to different dock positions. So if you'd like to move all of these to the bottom left, you can just go ahead and continue to click the 3 dots and then send it to the same dock position as where we sent the inspector. And there we go. Now we have our file system is our largest on the left. We've got our scene here showing our nodes, and then we also have our inspector on the left, and our scene that we're actively looking in is focused on the right. There is no specific way that this should be done. This is just however you would like it. For instance, your scene might become your most complicated part of your game, in which case you would like it to potentially be on the left. And we'll go ahead and move this over there. I've gone ahead and returned our editor to the default view. Another thing that we can do, since we're focused on making a top-down game, and we don't need to view the 3D scene, is we can go to our editor to the Editor tab and click Manage Editor Features. What we're going to do here is we're going to create a profile and call it Top Down. And this will open up a huge list of settings. You can get very detailed here, showing what is going to be accessible inside of Godot as long as we're on this particular profile. So the only things I'm going to deselect here are the 3D editor and then the asset library. And as you can see, those are instantaneously removed from the top here. We'll go ahead and hit OK. And as long as we have the top-down profile selected, this will be our view, and we have removed those features. So if that's something that seems like it could streamline your process, that's also something that you can go ahead and do. Of course, again, this is all just about preference, so you don't have to do this at all. And I'm going to go ahead and remove this profile just to take us back to our default view. Okay, so now we're here in our empty 2D scene. If your scene currently looks like this instead, that's okay. That means right now you're just looking at a 3D scene. There's two ways you can get out of this. You can go ahead and click the 2D button up here, which will switch you to the 2D scene view. Alternatively, you can go over to your scene dock here and click 2D scene. Now, when you click 2D scene, it will create a root node for you of node 2D. So what are nodes in Godot? Well, nodes are the most basic building block of a repeatable piece of code that can be represented visually within the game engine. So if we click on the node 2D and look at the properties over here in the inspector, we can see it's got certain canvas item properties. And most importantly, here in under node 2D at the top, it has a transform. The transform contains its position, rotation, scale, and skew. Now, scale actually refers to the size of this node. Rotation, of course, is the angle it's pointing, and then position is where it is in the game world. So that leads us into our next point, which is, as you can see by the inspector, we have a chain of inheritance here. We have a node 2D here at the top, which is the name of our root node. Then we have canvas item, and then finally node, which is process and editor description. So real quick, over in our scene, if we go ahead and right click, and we can go ahead and right click on node 2D, you can right click anywhere inside of this dock as well and add a child node. And you'll get this new dialog called create new node, and with the search bar up here. Now, before we dig into that search bar, we're actually going to collapse node here. And what you'll notice is that once you collapse that, there's nothing represented. And node, as well, is the same name as the very bottom set of properties listed in the inspector for your node 2D. If we expand this out, and I'm going to collapse these others for the time being, what you'll notice is that under node, there's also canvas item, again, which is above node in the inspector. If we open that up, we can then see node 2D, which is our top item here. So this inheritance chain is directly reversed in our create new node dialog and also shows how nodes relate to one another. And this is going to be important for what we're building on next. As we start to build out our player character, we're going to add a character body 2D node towards our scene. And the character body 2D node will be the most important part of our player character, will be the most important node here. And as you notice, once again, even as we search for character, we can see the inheritance chain here. So the character body 2D inherits from physics body 2D, which inherits from collision object 2D, and so on and so forth, all the way up to node. So go ahead and search for character body 2D in the create new node dialog and click create. So again, we'll ignore this little warning right here for now, and we're going to talk about our inspector over here. So at the very top, we have character body 2D, the name of our node here, along with its set of unique properties. Then collision object 2D, then node 2D, canvas item, and node. Again, we have that chain of inheritance here. What we're going to do next, and that's what this warning is telling us about, is we're going to add in a collision shape. So go ahead and right-click on character body 2D, click Add Child Node, and go ahead and search for collision shape 2D. Again, we can see the inheritance change, so collision shape 2D inherits from node 2D, coming from canvas item, coming from node. So go ahead and click on collision shape 2D and click Create. So from here, and I'll touch on this briefly as just an introduction, we get our idea of composition as opposed to inheritance. Right, so character body 2D has this inheritance change, ultimately inheriting properties all the way from node. Same as node 2D, and same as collision shape 2D. However, by the time we're now here in character body 2D, we're beginning to build out our character body 2D node horizontally, and this is called composition. So the reason this is called composition is because character body 2D, while being made of collision shape 2D node, isn't inheriting from collision shape 2D. Furthermore, we could add a child node, and I'm just doing this as an example. This will not be important to our character movement, but we could also add a timer node to our character body 2D. This node is now a part of character body 2D. It helps compose character body 2D. However, it's not directly inheriting from character body 2D. Now that being said, timer, like all of our nodes, does have an inheritance chain and calls back from timer up to node. However, we have now taken our character body 2D and we've built it out through composition. Okay, so for now though, we can go ahead and get rid of the timer and continue building our character movement. So let's go ahead and delete the timer node if you added it. And let's look at our collision shape 2D and look at its warning. So here we can see that a shape must be provided for the collision shape 2D to function. So what this is indicating is that it wants a shape to know as a collision where is it going to hit something. So you can go ahead and draw any of these. We're going to go ahead for now and do a new circle shape 2D. And here we can go ahead and see that shape. So the reason why we want to do a circle shape is other shapes are acceptable. However, things like squares can get difficult when players are navigating against walls or potentially other enemies. When it's a circle, things typically have a smoother way to process their velocities interacting with each other, and things tend to be a lot smoother. Now that being said, can you use square collision shapes? For instance, if we go ahead and change this over to a rectangle shape 2D, yes, this is perfectly acceptable, and we will use this for other things in our games or in the future. However, this can be a little bit simpler when dealing with collisions if you stick with a circle shape. So from here, we can go ahead and we can increase the size if we would like from inside of the editor. Alternatively, as you'll notice, if you clicked on the circle shape over here in the inspector under collision shape 2D, some properties open up which you can then change from in here. This allows you to get very precise with the radius, so on and so forth. There's no one way to do this. For instance, if we were to go to our character body 2D, and you can follow along with this part or not, I'm going to add a child node, which will be a sprite 2D. And I'm going to currently move this above the collision shape 2D. And I'll explain what that does in a moment as well. Clicked on sprite 2D. In the inspector, under texture, click the empty dropdown, and we're going to click load. From here, I'm going to click icon and click open. Just to show a different method for doing this, let's go ahead and remove this from the texture. And over in our file system, if we want to, we can click on icon.svg and drag it up into that texture slot to the exact same effect as going through that dialog. Now, the way that nodes are represented over here in the scene dock is also their draw order. So that being the node at the very top is drawn first, whereas the node at the very bottom is drawn last. So it's a little difficult to see, but right now our sprite, since it is above the collision shape 2D, is drawn before the collision shape 2D, and we can therefore still see and click on this circle. And just to show this real quick, if we were to take the sprite 2D and drag it below collision shape 2D, we can no longer see the full circle there as the sprite is being drawn on top of this. Now, functionally, this has no effect in game, at least for these two properties. This is just something to be mindful of in the future in case it's something that you care about or something that is applicable to your game. Okay, so now that we have our character body 2D, and we've gone ahead and added a sprite just so we can see this better, and now that we have our collision shape 2D, we can actually go ahead and work on our inputs. So let's go ahead and jump into that. All right, so from here, let's go ahead and go up to the Project tab and click on Project Settings. From here, you should be able to see the Input Map tab. In this dialog, we can go ahead and add actions. Actions can be named whatever we would like to name them. For instance, since we're going to have our character move up, we'll name one up. You can go ahead and hit the Enter key, or you can click Add. Now, once this is added, you'll see a dead zone, and then you'll see this plus and this trash can. The trash can delete the action. Nothing surprising there. However, the plus then opens up a further dialog saying no event configured. So here, we actually have a list of possible events that could trigger this action. So you'll notice that you can add joypad axes and joypad buttons, mouse buttons, and keyboard buttons. You can filter and look through all of these as you'd like, but we're gonna go ahead and filter by event. So since this is for the up action, I'm gonna hit W. As you'll notice, this will immediately populate saying physical key code for W. We can also add any of these additional options for this particular action. So now that we've gone ahead and added our W here, what we'll be able to do from the code is check if the up action has been triggered. So the neat thing here is that we can go ahead and add other keys to this particular action. So I'm going to hit the up arrow on my keyboard and click OK. So now if the user hits the W key or the up arrow, it will trigger this singular up action, which we will be able to call and check from the code to see if the player is trying to move in that direction. As a quick aside, before we create the rest of our actions, you can also click Show Built-in Actions here. And these are actions that are already predefined by Godot that you can call in the exact same manner in the code. You still have this complete control over all of these. You can modify them or remove them. However, it's useful to note that these are already here. A lot of UI movement is set up if you're interested in building that into your menus. So we're going to deselect Show Built-in Actions. Okay, let's go ahead and populate the rest of our actions. So we already have up, so now we're going to type in down, left, and right. And so from here, we'll again add our events. So for down, that'll be S, and the bottom arrow. And for left, that'll be A, and the left arrow. And then for right, that'll be D, and the right arrow. Now again, we could build this out by including axes for joypads and joysticks. However, while we will talk about using those in the code, we won't implement this in our input map for now. So now that this is set up, you can go ahead and hit close. Okay, so right before we jump into the code, there's one other thing that we want to update on our character body 2D node. If we go ahead and click on it, in the inspector, right under character body 2D, where it says motion mode, by default it's set to grounded. This works best for games like side scrollers. What we're going to want to do is change this to floating. Now this actually changes how the physics in move and slide, which is a function we'll call to ultimately move our player, are calculated. Floating is best for top-down games, or as described by the Godot documentation, it's for games that don't have a notion of a floor or ceiling. And again, as we're doing top-down and we're not worried about the player falling or jumping, that is going to be the best motion mode for us. Okay, so from here, let's go ahead and again, make sure your character body 2D node is selected. And we're going to hit this icon right here to attach a new or existing script to the selected node. Alternatively, you can right-click on the character body 2D node and click the attach script button. Either way will attach or create a new script for this node. We'll go ahead and click this button here, and it opens this new dialog. Here you can choose to name the script, where you'd like it to be, what it inherits from, so on and so forth. By default, it is in GDScript. However, for this particular video, I'm going to change this to C#. Now, if you'd like to do this in GDScript, you can still follow along as the code is nearly identical. However, if you would still like something more explicit, I do have a video already covering how to do this in GDScript. So for now, we'll stick with C#. And this would be more familiar if you're coming from another engine like Unity. And it is itself slightly faster than GDScript and could provide performance benefits on a bigger game. So other than that, we'll stick with all of these defaults for now, and we'll click Create. Okay, so this will take us into our script view. I'm going to go ahead and click this button up here to give us a little bit more view of what we're looking at here. So what we're going to do here is we're going to get rid of everything besides physics process. And we are actually going to leave this constant at the top for speed. So let's get rid of all of this in physics process, and we're going to leave move and slide. Now, real quick, this is a public constant float. We're going to remove the constant keyword, and then right above this, we're going to add a tag that says export. Now, in GDScript, this would then appear in the inspector for this node. However, with C#, before we can access that, we're going to need to build our project. So you can hit Alt-B on Windows or Linux to build. Alternatively, you can click this button up in the upper right to build the project as well. Once it's finished building, you will see the speed variable over here under character body 2D, where you can then edit the speed from outside of the script. So there we go. You can now see speed here, and you can go ahead and change this inside the editor. However, something you'll notice is that changing it here does not change it in the script. Now, you can always click this button and return to the value that you set essentially as the default here in the script. But just note, while this is good for quick testing, if you're trying to figure out what a good speed might be, I would ultimately recommend that whenever you settle upon a variable, go ahead and set whatever this value is in here to match that value. Okay, so focus back into the code. Let's go ahead and expand the script area up again. Okay. So first and foremost, let's go ahead and define a new function called handleInput. This will be a private void called handleInput. We don't need any parameters at the moment, and we'll just proceed like this. The reason I have declared this as a private is because we do not need to access handleInput anywhere outside of this player script. Okay, so let's go ahead and declare a new vector 2 called movement direction. And sticking with code styling best practices for C#, the first letter for this variable inside of a method will be lowercase. And this will call input.getVector. And from here, we are going to put in the names of the actions that we declared in our input map. Now, the order of these parameters does matter. If you move these around, you'll notice that your up action is maybe making your character move to the left or to the right. Now, what getVector does is it takes any of these actions and has a 1 or 0 value assigned to them and assigns and creates a vector based off of what you have, what actions are being pressed here, and puts that into movement direction. So from there, if we then have our velocity equal to the movement direction times speed, we will then move at our speed in the direction that the player is pressing the actions down to. Now, ultimately, we still need to call handle input down in our physics process. So if we save, and we'll need to add a semicolon there. If we save and build our project, Alt-B again builds the project. And then go ahead and play our scene, and it will build again. We can see that our player character is moving around. Now, it's not looking at the mouse yet. We haven't put that in. However, our character is moving. Now, before we delve into looking at the mouse, something else I want to touch upon. If you'd like to use something like a joystick, getVector may not be your best way to do this. So if you would like something that's, say, more fluid, if they're not moving the joystick all the way forward, they're maybe moving at a slower speed than if they were all the way forward. What you can alternatively do is, we'll go ahead and create a float called horizontal direction. And it will be equal to input.getActionStrength. And now we're going to type in our action. It'll be right. And then I'm going to copy and paste this for the sake of speed. And then this will be minus left. Now, the reason why it's in this particular order is because we're taking our positive value and subtracting it from our negative value. So if we go back to our 2D scene, what you'll notice by the numbers up here is that positive goes to the right, negative goes to the left. And you'll notice in the y-axis, positive goes down, negative goes up. So that will affect how we subtract our vertical direction. So I'm going to go ahead and copy and paste that whole line because now we need to get the vertical direction. And so we're going to look at our getActionStrength for our first one. And since it needs to be positive, the first one's going to be down in this instance. And we're going to subtract up from it. So let's go ahead and hit save. We still need to add our semicolons. Now, before we assign movement direction, which we have not specified yet, we need to create our movement direction vector. So what we're going to do is we're now going to define movement direction again. So vector2 movement direction. And it's going to be equal to a new vector2. And we're going to pass in as our values horizontal direction for the x-axis and vertical direction for the y-axis. And now, when we build our project again and go into our scene, since I'm using a keyboard, we won't see any difference here. Okay, so we'll notice it built and there was an error, and that's because I forgot to put the 2 at the end of vector2. So if we run that again and let the project build, we shouldn't have any issues this time, unless I miss something again. Okay, and there we go. Our character is still moving. Now, if you notice something, now, if they move in the diagonal direction, they speed up. And that's because our vector isn't normalized. So using this method, before we assign our movement direction, to our velocity, we need to normalize the vector value. So we'll go ahead and hit movement direction is equal to movement direction dot normalized. Hit save, and we can run our scene again. And this time, when we move diagonally, the speed is the same as when we're moving in any of the left or right or up and down directions. Okay, so let's go ahead and add in the ability to rotate towards the mouse. Now, all of this is handled by built-in Godot functionality. So we're going to call right below handle input in the physics process method, we're going to go ahead and call look at. And then inside of here, we're going to type get global mouse position, which is itself a function. Now when we hit save, and we add a semicolon, save again. And then when we run our scene again, this time, not only is our player moving, but they're also looking at the mouse. Now, one other thing that we can and should do here, and we'll need to drastically increase the speed as a result, is we should multiply our speed by the frame rate. Now, the reason to do that is because frame rates, while a maximum can be set by your game, the frame rate that a player ultimately gets is determined by their hardware, sometimes by internet connection, so on and so forth. What that means is that if you say have your player be able to travel at, say, 1 foot or 1 meter per frame, right? If you programmed that with 60 frames per second, 60 FPS in mind, then that might feel good to you. However, depending on what the game is doing at the moment, or what the hardware as a whole is doing at the moment, or if it's a brand new computer or a 10-year-old computer, the frame rate could be drastically different. For some person, they might be getting 20 frames per second, whereas someone could be running at 120 frames per second. So our way to normalize this is to multiply the speed by the delta. So delta is also sometimes called delta time, and what that is that's the difference between this current frame and the previous frame. So multiplying our speed by the delta then allows us to ensure that we have a consistent speed no matter what the player's frame rate might be. Let's go ahead and pass the delta parameter into handle input. We'll also need to declare it as a parameter in the handle input function. So we'll again, similar to how it's done in physics process, we'll declare a double delta. And then down here in our speed calculation, we're going to add one more multiplication, and that's going to be times delta. Now, since delta is a double, and these are a float value and then a vector value, we're going to need to convert delta to a float as well, or cast it to a float. Now, there's no need to do this. However, I'm going to put speed and delta in their own parentheses just so we understand that the movement direction is separate from our speed calculation. So we can go ahead and hit save, and we can build our project again. Now, delta, since it is the difference between frames, is incredibly small. So given that we didn't change the speed, our player will be moving incredibly slowly. You might be able to see it, but it is moving slowly. So I'm going to go ahead and update this to 1,000. We'll save, and we'll build again. Okay, you can see it moving a bit better, but perhaps there's a reason to expand that even further. I'm going to now set that to 5,000. We'll save, and we'll run this again. Okay, that is then sort of similar to the speed we were getting previously. However, now our speed would be consistent over changing frame rates between different hardware. Okay, let's go ahead and jump into setting up a camera for our player as well. Okay, right before we create our camera, let's actually update our scene structure a little bit here. So now that we're done with our player, we actually have one more thing we want to do. So clicking on the character body 2D node, and then over by the inspector, we want to click the node tab. Okay, if you didn't see anything there, just make sure that you've selected your character body 2D again, even if it's visualized over on the left side. So inside of the node tab, we then want to click groups. And from here, we're going to type player and hit add. Now you'll notice there's now a new symbol next to our character body 2D, which notifies us that this node is in a group. There's also another symbol that specifies that there's a script attached to this. If we were to click that, it would take us directly to that script. So before we work on our camera, let's go ahead and right-click on character body 2D, and let's go ahead and rename this to player. From there, what we're going to want to do is, again, right-click on player, and then we're going to actually click Save Branch as Scene. So this will take this node and all of its child nodes and save them as their own scene. Right now, our file structure is empty here. What I'm going to do is I'm going to create a new folder to keep us organized called Entities. For me, this folder holds all the things in the game that move or can interact with each other. So that could be, for instance, depending on the game, that could be a player, it could be an enemy, it could be a crate, it could be a sword, it could be tree, anything like that is what I envision coming in here. So even though scenes, while there are player, there then also are game scenes, such as the world that they're interacting in, I do like to keep them separated, hence I create this entities folder. So go ahead and hit OK to create the entities folder. Now that we're in here, we're also going to create another folder called player. Okay, and right in here is where we're going to save our player. So now in our file system here in the bottom left, you can see the entities folder, the player folder, and then the player scene. What we're also going to do is click our character body script, and we're going to drag it into the player folder. So now those are nicely kept together. Another thing you'll notice is that our player node is now a unique node, and you're no longer able to access the nodes beneath it. So instead, we again have a new symbol here appear on the right, and that is a scene symbol, and it says open an editor. If you click this, a new scene tab will open, and now we can see all of those nodes again below the player that we can interact with again. Okay, we'll close this scene for now and go back to our scene that we're working in. Right now I've titled it Node 2D. And what we're going to do is we're going to rename this Node 2D node, and we're going to name it World. And I actually mean to capitalize that. There we go, World. Okay, now let's go ahead and work on our camera. So go ahead and right-click on the World node, click Add Child Node, and type in Camera. There we are. Since we're in a 2D scene, we're going to use a Camera 2D. Okay, great. So from here, what we're going to want to do is attach a script. Again, we'll leave it in C# and leave all of these defaults. And let's go ahead and hit Create. Okay, I'm going to expand this again. And here's our default camera script. We're not going to need ready, so I'm going to go ahead and get rid of this right off the bat. Okay, so inside of our process, what we're going to need to do is find our player in the scene, and then we're going to want to follow the player. So what we're going to do is going to declare a node 2D called player, and it's going to be equal to get tree dot get first node in group, and then we're going to pass in the name of the group that we assigned the player. Now for us, we want to grab the first node in the group because there's only ever going to be one player in this game. Now from there, what we want to do is we're going to set the position of our camera equal to the player.position. Now, this itself could be acceptable. However, depending on how you have your gameplay, there might be instances where the player is not in the scene. As a result, this would then cause an error because it would be trying to access the position of something that may or may not exist. So what we're going to do to be safe here is we're going to add an if statement where we check if the player is equal to null. If it is, we're going to return, and we don't want to do anything from there. Okay, so let's go ahead and go back to our scene. And if we hit play, we have an error. And that's because what we've done here is we've set our player is a node 2D. However, get first node and group actually returns just the base node, not a node 2D. Now we know our player is of a type node 2D. That's what it inherits from. So the way we can fix this is by casting this. When we get this node, we're going to say grab it as a node 2D. Okay, so we can save that again. We can build our scene and play it. And this time, we'll be able to move our player around with the camera attached. Now, right off the bat, you're not going to see any movement. And that's because we have an all gray background and the camera is attached to our player. You might see some jittering, and that's as the camera tries to follow the player. So let's go ahead and exit out of this. And we'll go back to our 2D scene. Let's minimize here. And then looking at this, we're going to go ahead and add a quick background. Now, depending on your game, this would be an instance where you would add something like a tile map. However, I'm going to be very simple here and just work with what we have already in our project. And we're just going to add a big Godot logo as the background. So we'll drag the icon up into that sprite 2D that we've added to the scene under the world node. And we'll just make it fairly large so that we've got something we can move that we can see our player moving against. Now, if you notice, right, we can't see our player right now. We can only see the sprite. And that's because of the draw order we talked about earlier. So with sprite 2D at the very bottom, that means it's the last node drawn. So go ahead and click sprite 2D and drag it up to the top so it's the first thing drawn under that world node. And there we can see our player again. So go ahead and save and run this scene again. Once this loads in, we can see our camera following our player along. Okay, now I'm going to click on our player again real quick, and I'm going to change our speed from 5,000 to 10,000. And I'll save that just in case. Now going over to our camera, right now our camera has the position of the player exactly. If you would like to smooth its movement, which might feel a little more natural, but this is purely opinion based, you can go ahead and click on the camera 2D. Under the inspector, below camera 2D, there's position smoothing, and you can enable it by clicking on. You can then get more specific by specifying the speed with which the smoothing can be done. If we run our scene again, we can see that the camera lags behind the player a bit, and when we stop moving, the camera smooths to the player's location. Okay, let's X out of that. Now, there's another way we can do this, and we can also do this in the code by lerping. So, is this smoothing bad? No, not at all. This is purely opinion-based, but that particular smoothing there is linear. Lerping, on the other hand, actually is a little bit smoother and speeds up as it moves towards the target and slows down as it gets closer towards the target. It might feel more natural. Then again, you might prefer the linear version. There's no best way to go about this. It's whatever feels best to you. So for now, we're going to deselect the position smoothing. And we're going to dive in to our camera script again. Okay, so we're no longer just going to be setting the position to the player position. Instead, what we're going to do is our position is now going to be equal to our position dot lerp, and then in the parentheses, we're going to now pass in player position and make sure that the P for position is capitalized. And I'm going to go ahead and expand this again. Okay, and our second parameter is going to be float delta, since we need to cast delta as it is a double to a float. And that's going to be multiplied by a variable that we're going to define called follow speed. Okay, let's go ahead and set our follow speed. And this is going to be a private variable, a private float, since we're not going to need to interact with this outside of the camera class. And it's going to be equal to a value like 5. Make sure you add your semicolons. Let's save, and let's take a look at this movement. Let's go ahead and run our scene. And as we move along, you'll notice a similar sort of slowing going on. And it might be, at this rate, so similar that you can't tell it's happening. So let's go ahead and X out of this. And just so that we can see exactly what's going on here, let's change our follow speed to 1 and run our scene again. And now you can see how that lerping slows along and gently settles into the player's position as it gets closer. So again, is this smoothing better than the smoothing provided by the camera node by default? That's purely opinion-based and whatever works best for your game. Alternatively, if you don't want any camera smoothing, that's also something that may just work best depending on what your game is. So let's go ahead and go back to our scene. We'll minimize this. And to finish this off, we're going to go ahead and inside of our entities folder, we're going to create a new folder called camera. And we'll go ahead and move our camera script under the camera. Okay, and those are the basic fundamentals of top-down character movement in Godot. Thank you so much for watching, and for more tutorials, follow Tenderfeed and Supply Co.